good.
Okay, so we're going to look at the oil system, and there's actually, if we, Charles, turn around, underneath this concrete pad there are two large oil tanks, and they've got those red cones on the top, and those are our underground storage tanks. And then what we will do is we will pump from the underground storage tanks into our day tank, which is this guy that's behind this cage. So now if I open up the cage door, you look at the top of the tank, there's a yellow transmitter up there. And that yellow transmitter is a radar transmitter, guided wave radar transmitter. So there's a cable going down. It almost touches the bottom of the tank. It's not perfectly accurate because there's a weight on it, which is about that long, and about that round. So it holds down straight. And the guided wave can only go down as far as that cable point and come back up again. So there's about 5 centimeters error. There's still some oil left in the tank when this thing says that it's 0. Now, what we're going to do is I'm going to put some of this stuff, which is water finding paste, on the end of a dipstick. And what it does is it, when I put it on, you can see the color of this. It's yellow, and if there's any water in that oil, it's going to turn red. And so that we're going to test to make sure that there's no water. And this is typically used on boats like pleasure craft that have got diesel engines. So what I'm going to do is I'm going to put a little dab of that on here, on the end of my oil stick. Then what I'm going to do is I'm going to put it down. Now it's water, specific gravity 1. Oil is running at about 0.85, 0.87, something like that. And so the oil is going to float on the top, the water is going to be down at the bottom. So when I take, and that's why I put this little dab right near the bottom, so that when I go down in the tank, it's going to be in the water if there is any water in there. The water will have separated from the oil, but as we're pumping out of there, we could be bringing the water with us. Okay, so I'm going to go up. Okay, so I'm going to open up this nozzle, and this is where the oil company would come to fill it if this was normal, but in our case we're pumping it out of our underground tank. So now I'm going to take my stick, which has got my paste on there, put it down in the oil till it hits the bottom. So I'm on the bottom, leave it in there for 10-15 seconds. It doesn't take very long, and then lift it back up. I want to see a couple of things. I want to see where the oil level is, and right now the oil level is, you can see the bit of shiny oil right there, and the oil level is sitting at 47 centimeters. And then my paste is still yellow in color, which means there's no water down there. If there was water down there, it would have turned red. So following the oil system through, we're going to pump from the day tank down to the oil pump, which is located down the basement. So we've actually got to go down these stairs. So our day tanks are located back behind this wall. We're underground right now, we're in the basement. And so we got 2 level gauges on here, and the level gauges are showing levels in there. They got a pump in here, which you're supposed to pump. And when it no longer will go any higher, it's now showing you the level. So it's saying that we've got 4,000 gallons in that tank, or just under 4,000 gallons in the tank. Oil tank number 2 said it was empty, but once I pumped this thing up, it says we got about 4,500 gallons in that tank. So what kind of a device is this? How do you think that that thing is operating? I was pumping it. It's a bubble pipe. It's a simple bubble pipe. And rather than bubbling air through it continuously, you just hand load it. You're not going to put an excessive amount of air into the oil. So this is typical of the old level meters. And you might look at that and say, gee, that's old-fashioned. And you're right. This was built in 1964. However, behind me here is another one. Okay, and I won't bother pumping this guy. But this is on that brand new day tank that we put in there. Well, it's not brand new now, but we put it in 2011. And it's using exactly the same style gauge. Now, we got fancy with it in that we put a radar gauge on there. But that gauge is actually showing you what the level is if you were to pump it. Okay? Okay. So the oil that's coming in comes in right here from the day tank. Okay, so this is drawing out of the day tank. So it's actually pulling the oil up and around. This can be a bit of a problem because if you have to prime this thing, you actually got to try and push oil backwards through here and get it primed. That'll only happen if you run the tank out of oil. If you don't run the tank out of oil, then it'll stay full. So now we come down. We got to open up this valve when we're ready. We're going to go through that heater. You do not need to heat number 2 fuel oil. It's diesel. However, we have designed the system so that we could be running other fuels, alternate fuels, like tallow. And if we were using tallow, which is fat, it would need to be heated. Okay, and so we've got electric heaters to heat it. Now, we've only run it on oil, but we can run it on tallow or other fuels if we wanted to. It comes out of there on this the line that goes to the suction of the pump. And that line right there goes along, goes into the pump, and goes through that little tiny pump. That's a positive displacement pump. If you get in that pump, it'll burn out in next to no time at all because it's basically a gear pump, and it's got to have a flow going through it. If it starts to spin with no flow, it'll heat up very, very quickly and then literally burn itself up, which did happen to it during startup because they did not have a proper valve on the discharge to make sure that you maintain the minimum flow, which was a problem with everything in the design the designer came up with. The discharge oil comes back up on this line here and goes off of here and heads out there to the boiler. So we're going up, and it says now boilers because we can send oil to the Nebraska boiler. We can also send it to the View boiler. So we just recently set the View boiler up to do that. So this valve would have to get over. Now, so that we maintain a minimum flow on here, what we've got is we've got a control valve that's sitting in here. And it takes this oil that's going to the boiler. If that was closed, it would come through this line here around into this control valve. This valve is set for a minimum position of 10%. It'll never close off. Then what happens is that oil comes out of this valve and recirculates back to the day tank. So you've always got a minimum flow going through here. Now, to get and maintain our pressure controller, we do this the same way we did with the feed water control. This is going to be relief control. So when we first start that pump up, the pressure is going to come up, this valve is going to open up and bleed a whole bunch of oil back to the tank to maintain the oil at the set point pressure that we want. Once we start to draw oil to the boiler to actually fire, this valve will progressively throttle down, 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 because oil is going to the boiler, so you'll be recirculating less back to the day tank to maintain the pressure constant. The pressure transmitter is upstairs, and this is its final control element. Okay? Okay, so the oil is coming up from the basement on this line here, and it hits this cross, and off that cross we're actually going to this oil pressure transmitter. So this transmitter goes back to the controller to the DCS, and then the DCS actually controls that valve that we just looked at downstairs to modulate this pressure and hold it constant. The oil can come off of this cross and then go all the way through the floor and end up over at the view boiler, which is sitting over there. And the view boiler, if we wander over to it, has oil coming up from here through a regulator, through a mass flow meter, through a control valve, double block valves, no bleed valve, you don't want to bleed oil, and then from there it comes around the corner, it goes up into where the oil burner would go, right in there. Its oil burner looks like this. It simply goes in like that and then gets locked in place. Okay. This boiler is actually kind of neat. It's different from the other boiler. You need to have atomizing steam. Where are you going to get the steam from if everything's shut down? So what he has here is, this is a straight pressure nozzle, not atomized. Just it's atomized by the nozzle there. And so for startup purposes, you throw that gun in, you light off, you don't change the flow rate, constant, you make a head of steam. Then you shut down, pull this burner out, put the other burner back in, and then using the atomizing steam coming off the drum, you can actually light off and away you go. This runs very nicely. Okay, we're going to go to the Nebraska. So very similar, the Nebraska takes oil off of here, which is controlled by the pressure control, comes down through here, a regulator, just like we had on the View, Coriolis mass flow meter, similar to the one we got on the View. This one is a little bit more accurate, it's a newer design. Then from there to the oil pressure switch, which is part of the interlock. Okay, and this is set for 55 pounds. So if your oil pressure drops below 55 pounds, this thing is going to trip out. Well, we're up at 100 pounds, so no problem. Through the oil flow control valve, which is only running at 4% open for light-off purposes. Then through the double block, this one quick opening, this one slow opening. The double block, no bleed. Okay. And then from there to another oil pressure switch, through another block valve, through this line, up to here, and then the number 2 fuel oil is actually going to come in here on this line here. Now, we don't have the gun in, and we're going to go through all that stuff when we do oil light-off with you. But this now shows you the oil train. The oil guns themselves look like this. They are very long. Okay? And as a result, it sometimes takes many attempts to fire the boiler because you've got to fill all these lines and that gun to get oil coming out the end of it. And you're going to limit this valve for light-off purposes. So sometimes it'll take 2, 3, 4 attempts to actually get oil to light off. Okay?